Hello, ladies and gentlemen. Today we are going to be talking about section 2 here in our trigonometry unit, our first trig unit. So this is about applying trig ratios. So what we're going to be doing today is basically solving problems using trigonometry. Mac is going to be joining us periodically, I'm sure. So we are going to firstly talk about a couple of terms that we need to know in order to solve real-world problems with trigonometry. And those are angle of elevation and angle of depression. Hi, Mac. So we are going to be using those. And this is sort of a diagram that is telling you where those angles end up. So angle of elevation is going to be the angle measured from the horizon or from the horizontal upward. So what we're going to write here is the angle between the horizontal and something above. So angle between the horizontal and something above. That one's pretty straightforward. People tend to do fine with angle of elevation. The one that people confuse is the angle of depression, because the angle of depression is measured from the horizontal to something below it. And oftentimes when people think, oh, the angle of depression for this man looking at this dog, they think of this angle down here. That's not the angle of depression, though. The angle of depression is actually measured from the horizon, from where you would normally be looking if you looked straight forward, and then downward. So this is the angle people are talking about when they mention angle of depression. So we're going to say that's the angle between the horizontal and something below. Angle between the horizontal and something below. All right, so we're going to use both of those terms today. We're going to be solving trig problems that are basically story problems. These are problems that are sort of basic, but they are used to show the ways that trigonometry can be used. So a lot of the problems that people use trigonometry for in regular jobs, regular everyday applications are a little bit advanced in terms of the science that you would have to understand in order to understand the trig problem, or the engineering vocabulary you would have to know. So we tend to simplify the problems when we're teaching you about trig ratios, and then you can use them later on if you need to in a job when you have more of that vernacular is the word that they use to talk about specific vocabulary related to a certain job field. We're just going to do simple problems today. So for problems involving trig, we want to, first of all, always draw a diagram if we're not given a diagram. It's super, super, super helpful because we need to figure out what angle we're going to use as our angle of theta. And if we don't draw a diagram, it can be really confusing to decide, oh, what's the opposite side? What's the adjacent side? It's hard to see those things without a picture. The next thing we need to do is we're going to find the appropriate trig ratio. So if we're solving for a side or an angle, we need to say, well, does the information that we already have lend itself to us using cosine, lend itself to us using tangent? We have to decide which would be the best trig ratio to use in that situation. Oftentimes there are more than one. And then finally we have to solve for the variable in question. So they're going to be asking us, how tall is this tree? Or how far away is this object? Or what is the angle we're looking for? And then we're going to solve for that variable. So here is the first one. This is actually a pretty difficult one for our first problem, but that's okay. We're going to get simple ones and harder ones in here. So to an observer on a cliff 350 meters above sea level, the angle of depression of a ship is 28 degrees. What is the horizontal distance between the ship and the observer? So let's draw this picture. There's an observer on a cliff. So there's this cliff, right? Here's our cliff. Here's our little person on the cliff. He's really small. And the cliff is 360 meters above sea level. So 360 meters above sea level. So we'll draw the C down here. What is or the angle of depression rather, of a ship is 28 degrees. So I'm going to draw a boat down here. Don't know how to draw a ship, but we'll draw a sailboat. So the angle of depression of a ship is 28 degrees. So we have this observer up here, and he's looking at this ship, all right? And his angle of depression is 28 degrees. And this is where we have to think about, all right, what is an angle of depression? Because this down here that makes our triangle, that's not the angle of depression, because that's not being measured from the horizontal. If this little person looked forward, they would be looking straight this way. So the angle of depression is going to be this right here, okay? This is the angle of depression. That's the angle that's 28 degrees. And we're being asked, what is the horizontal distance between the ship and the observer? So that would be this distance down here, okay? This bottom distance right there. We're saying, what is that distance? Well, there are a few ways that we can approach this problem, and they all have to be a little bit complicated because we are talking about the angle of depression. So we could find the complementary angle to 28 degrees and use it down here, and then that would be our theta, using this 360 meters and then finding this distance. We could do that. We could also just use this 28 degrees and use what we know about geometry and say, well, if this is 360 meters, this is still 360 meters, right? It's just a rectangle. And if this is the horizontal distance between the boat and the cliff, this up here is also that same horizontal distance. So we can use this triangle instead of the one underneath of it to do our trigonometry. And that's what I think we're going to do, just because then we have our 28 degrees here and we don't have to find the complementary angle of that. So here, we've got our 28 degrees, and we have information about the side opposite, and we're looking for the side adjacent to our 28 degree angle. Well, which trig ratio uses opposite and adjacent? Tangent uses opposite and adjacent. So I can write an equation. I can say that the tangent of 28 degrees is going to be equal to the opposite over the adjacent side. So I can say that's 360 over d. Okay? And then I can just solve this ratio, and that's going to give me the horizontal distance that I'm looking for. So I'm going to say, all right, if I multiply both sides by d, we've done this before, so I have d tangent of 28 equals 360, divide both sides by the tangent of 28. Mac is playing with a toy with bells on it, so if you hear that, I apologize. So we've got d equals 360 divided by the tangent of 28. All right, and we can easily put that in a calculator and figure out what it is. So remember that your calculator should be in degree mode. It's not going to change back if you had it in degree mode before, but just make sure it's in degree mode now. So we've got 360 divided by, I'm going to put a parenthesis here, tangent of 28, close both my parentheses, and that gives me 677.06. Let's see here. So 360 divided by tangent 28, d equals 677.06. So that's what we're going to say is d. That's our horizontal distance, right? So we could say that is 677.06 meters is our answer. All right, because we found that side of our triangle. All right, let's do some more. We're going to kind of speed through these maybe a little bit quicker, just because I think you might have the idea already. So we're going to draw a diagram from a point on the ground 47 feet from the foot of a tree. All right, we're going to draw a little simple tree here. There's our tree. And we are 47 feet from the foot of it. Okay? The angle of elevation of the treetop is 35 degrees. So if this is the horizontal, we're going to make the angle of elevation to the treetop 35 degrees. All right, and then it says, what is the height of the tree to the nearest foot? Well, we've got our right angle. We know that trees grow perpendicular to the ground. And we have our theta, which is 35 degrees. We have information about the side adjacent to theta, and we're looking for the side opposite to theta. So we're thinking about which trig ratio uses opposite and adjacent. That's going to be tangent. So we can write the tangent of 35 equals our opposite side, we can call that x, over 47. All right, and then we just solve this. So we're going to multiply both sides by 47. We get 47 tangent of 35 is equal to x. And then we just figure that out. So 47 tangent of 35 is going to be 32.91 equals x, but it did tell us that we wanted to round to the nearest foot. So we're going to say that's close to 33 feet. All right, so that tree is 33 feet tall. All right, this is a useful thing to be able to do. Maybe not necessarily for measuring trees, although sometimes it would be, right? You might not be able to take a measuring tape all the way up a tree, but if you had a protractor or some kind of angle measuring device, you could find the angle of elevation from where you're looking at the tree, and you could measure your distance away from the tree, and that would be able to tell you then how tall the tree was. But people use this for bigger ideas. People will use it to measure how far away from us a planet might be if they know their angles and their horizontal distance between the points where they're measuring, things like that. Here's another one. Luckily, we have a diagram here. An 8-foot metal guy wire is attached to a broken stop sign to secure its position until repairs can be made. Attached to a stake in the ground, the guy wire makes an angle of 51 degrees with the ground. How far from the foot of the stop sign is the stake? This is our distance we're looking for, to the nearest tenth of a foot. So here, we've got our theta angle, our angle in question. We have information about the adjacent side, or we're looking for the adjacent side, and we have information about the hypotenuse. So we say which trig ratio helps us with adjacent and hypotenuse. That's going to be cosine. So let's make the equation. We're going to say the cosine of theta, so the cosine of 51, is equal to adjacent x over opposite 8. Right? And then we can figure this one out. We can say, all right, multiply both sides by 8. So we've got 8 cosine of 51 is equal to our x value that we're looking for. So easy peasy, 8 cosine of 51. And that's going to be 5.03, so 5.03 equals x. And of course, we need to round to the nearest tenth of a foot. That's going to be a 5.0 feet. And that is our answer. And again, this might be kind of a silly application because we could just measure this distance. But in other ways, in other applications, you're going to not be able to measure a distance that you're looking for using trig. Next page, we've got some trickier examples. They're really not that much trickier, but I put them in here because they sometimes illustrate different parts of what we're talking about. So this first one has a diagram. This first one's actually very similar to our first problem of the day. It's not that difficult. From the top of a 108-foot lighthouse, we're going to write in that value here. The 108-foot lighthouse. The angle of depression of a boat at sea is 27. Notice where they've drawn the angle of depression here, right? This angle of depression is measured from the horizon or from the horizontal. Find the horizontal distance from the boat to the base of the lighthouse to the nearest foot. So we're looking for this value, which is x. And so we could use this triangle down here, but we would need to find the complementary angle to 27, which isn't that hard. We can do that. We'll say that this is going to be 90 minus 27, which is equal to 63. So this angle right here is 63. We could create a new triangle over here and use 27, or we could use 63 and then this information that we know. We'll change it up from what we did last time, and we'll use this 63-degree theta. And we can say, well, if this is our theta, we want to know the opposite, and we have information about the adjacent side, right? We don't know the hypotenuse, but we don't need to. So we're going to say that this is going to be a tangent problem with opposite over adjacent. So the tangent of 63 is equal to x over 108. So then we're going to say, all right, that's going to multiply everything by 108. And we can say 108 tangent of 63 is equal to x All right, we'll put that into here, 108 tangent of 63. It's going to be 211.96 equals x, and then it says round to the nearest foot, so that's going to be at 212 feet. Right there. All right, and that is, again, the horizontal distance. We could label this 212 feet right there. Next one. Hi, Mac. How are you doing? All right. A flagpole, 18 feet tall, casts a shadow 12 feet long at a specific time of day. Let's draw that. Got a flagpole here, and it's 18 feet tall. We have it casting a shadow 12 feet long. There's its shadow. Put the little flag shadow there. At a specific time of day. Find, to the nearest degree, the angle of elevation of the sun at this time of day. Well, that's interesting because we drew a picture of a flag and a shadow. We didn't draw a picture of the sun. But we have to remember something that we might know from science, or something we might know from just being outside. If the sun is up here, the angle that it's making is the same as the angle from the shadow to the flagpole. Because this angle right here, that angle of elevation, it'll continue. This ray, this line will continue in that same vein all the way until it hits the sun, right? Because the sun shining this angle is going to make the shadow show up at that angle down here on the ground. So if we're looking for the angle of elevation, we're looking right here. Okay, this is the same as the angle up here. Anything that's being hit by the sun that day is going to be hit at that same elevation angle. So we want to find the angle. We don't know theta. We can put our little theta symbol in there. We don't know it. But what we do know about theta is we know that the side opposite theta is 18, and the side adjacent to theta is 12. So we can use tangent for opposite over adjacent. So we can say the tangent of theta, which we don't know, is 18 opposite over 12 adjacent. And because we don't know the angle, we're going to use our ratios. Well, obviously we're going to use our ratios. We're going to use our inverse trig function for this one. So we're going to say, well, if we don't know the angle, we're instead going to use the inverse tangent, or tan -1 on a calculator. And the inverse tangent of the ratio will give us theta. So the inverse tangent of 18 over 12 will give us theta. So let's do the inverse tangent of 18 over 12. We'll go second tangent, inverse tangent of 18 over 12. And that gives us 56.3. So 56.3 equals theta. So find to the nearest degree the angle of the sun. So that's 56 degrees is the angle of elevation. That's the angle that we could draw into our diagram right there. All right, a couple more here. A student lets out 100 feet of string on a kite from a hand height of 3 feet. So we've got a kite here, and there's a person holding the kite, right? And he's not holding the kite with the bottom of his foot. So the string of the kite is not on the ground. He's holding the string of the kite in his hand, right? We can draw him flying a kite here. And this is going to be 3 feet off the ground. I'm going to draw this little 3 feet marker. And he's holding the kite 3 feet off the ground. The angle between the horizontal hand height and the kite is 25 degrees. So not the ground and the kite, but the horizontal hand height and the kite. This angle right there is 25 degrees. Right? Find the height of the kite above the ground to the nearest foot. We want to find from the kite, not just to the hand, but to the ground. Okay? So we've got to do this in a couple pieces. You might already see where this is going. So we've got this distance that we should find. Let's see. Oh, we forgot to write the 100 feet of kite string. We should probably put that there. So the 100 feet of kite string, we're looking for the vertical distance. So we're looking for this value right here. So compared to our theta angle, we have the opposite of that, and we have the hypotenuse of that right triangle. So we're going to say that that is going to be sine, opposite over hypotenuse. So sine of theta, sine of 25 degrees, is equal to our opposite x over our hypotenuse 100. All right, let's solve that first. Multiply by 100. So we have 100 sine of 25 is going to equal our x value. So that's going to be 100 sine of 25 is 42.26. So 42.26 equals x. And that's only this distance right here. We still need to incorporate this, which you can probably already see what's going on here. We're going to have to add 3 feet to 42.26 to figure out the distance between the kite and the ground, because the ground is down here. And we just found the distance from the hand to the kite. So add 3 feet onto this, so plus 3, and that's going to be 45.26 equals x. So find the height above the kite, or of the kite above the ground to the nearest foot. That's going to be close to 45 feet above the ground. All right. Kites actually might be one that you could use a protractor to measure. So if you're interested in figuring out the height of a kite, if you have a protractor at home, you can measure the angle of your hand to the angle of the kite string and figure out how high your kite is by that. So something you could actually do. And then lastly, a plane has traveled 26 miles on a course heading 48 degrees east of north. How far has the plane traveled at this point to the nearest tenth of a mile? So sometimes transportation problems are difficult. Plane problems, train problems, car problems. So first of all, we need to know, here is our plane, okay? Where did our plane come from? Our plane came from an airport. So we'll draw our airport here. And it's traveled 26 miles on a course heading 48 degrees east of north. Well, compass rose time. Here's our north side. Here's our east side. And it's traveling 48 degrees east of north. So north is straight up. And it's traveling more east than that. It's traveling 48 degrees in a direction east of north. Here we'll make our airplane. And it says, how far has the plane traveled at this point? So it's traveled 26 miles as it has flown. But we need to know how far north it's traveled altogether. So we can say, well, what we're looking for is we are looking for this distance right here. So can kind of draw this line over here. We're looking for how far north the plane has traveled while it's been traveling east of north. So we have our angle in question, the angle that we know, theta, and we have information about the hypotenuse, and we're looking for information about the side which is adjacent to theta. We think which trig ratio uses adjacent and hypotenuse. That would be our cosine. So we're going to use the cosine of 48 is equal to x, hi Mac, x over 26, right? Adjacent over hypotenuse. So that's going to be then multiply by 26. So 26 cosine of 48 is equal to x. We will figure that out real quick here. 26 cosine of 48, and that's going to be 17.39 equals x. And then we can say, all right, nearest tenth of a mile, that's like 17.4. All right, so 17.4 miles is going to be our answer there. All right, so that is everything for today. Let me show you what I'm dealing with here. This cat has gotten so big. Mac, come here, look. She's so cute. Look how cute she is. But she's always involved in everything. Gotta zoom out. She's like a full-size cat now. She's like not even a kitten anymore. She's the cutest thing, Matt. Aren't you the cutest thing? Aren't you not supposed to be on the counter, Matt? Yes, of course you are. But that's okay. That's okay, because you're adorable, and I can't get mad at you, and it's probably a bad thing, because you're never going to learn anything, but that's all right again. All right, anyway, guys, I will talk to you another time next week, coming to you with another lesson. All right, see you later. Bye.